Good afternoon and a very warm welcome to our distinguished guests, esteemed faculty members, teaching staff, and all students attending today. I, Saksham Gaur, along with my colleague Pratham Gautam, we are your hosts for this keynote.
We are very delighted to welcome you to the 4th Biennial International Conference on Future Learning Aspects of Mechanical Engineering, FLAME 2024, organized by Department of Mechanical Engineering, ASAT, Amity University, Uttar Pradesh, Noida.
I would now like to introduce our session chairs for this keynote talk. Dr. Tikendranath Verma, MA NIT Bhopal, and Dr. Jitendra Katiyar, Chitkara University, Chandigarh. Now, I would like to request our session chair and student coordinator and faculty coordinator Dr. Shamil Samans to present the Tulsi sapling to Professor Dr. Atul Sagade as a token of gratitude. Today, our keynote speaker is Professor Dr. Atul Sagade, University of Tarapaka, Chile. The topic of his keynote talk is generalization of the test parameters and standards for the solar thermal cookers, importance and usefulness. He is a seasoned professional with a robust academic background in mechanical engineering, specializing in energy technology with over 15 years of experience. He has held diverse roles in teaching, entrepreneurship, and administration at engineering institutions. His career includes 7 years as principal director of an engineering polytechnic, followed by current positions as a professor scientist at prestigious universities in Europe and South America. Now, I would request our session chair, or I would request him to continue the keynote talk, please.
Good afternoon to everyone. It is a really hard session, I know. After lunch, it is difficult to hear something. So let us focus on this topic, generalization of the test parameters and test standards for the solar thermal cookers. As all of us know, solar cooker is one of the device that is useful for decentralized energy solutions. And in present era of wars, I'm not calling pandemics, wars, oil and gas scarcity is leading the European countries as well as US countries and Latin American countries to switch to renewable energy devices for cooking. So one of the decentralized energy, one of this device is solar thermal cookers, and we all aware with this. So let us go somewhat fast, because these are the basic devices that we know. There are different types of solar cookers, box type solar cookers. Then recently IOCL launched Nutan Chula. It is with storage type of device, backup by electricity and solar electricity or electricity generated by the solar panels. Then concentrating type of solar cookers. Then you can see evacuated type, that are the picnic type of cookers, these one. Then funnel cookers, a lot being used in Europe, particularly because of low level of radiation as well as latitudes. Then there are some different cookers like indirect cookers, or we can call it as advanced solar cookers for indoor cooking as well as outdoor cooking. In this type of solar indirect cooking, indirect solar cookers, there may be a concentrating type of device, and it transfers heat through heat transfer fluids into the cooking chamber located in a kitchen. Surya Nutan Chula is similar one, but it is not operating directly on sun. It is operating on electricity generated by the sun. Then we know in different places in India, we have this type of Scheffler systems, like places like Shirdi in Maharashtra, then Tirupati, Mount Abu, everywhere we can see this type of cookers. Then PV cooking, as we know, PV giving electricity to the induction cookers, and they are generating required voltage and current to get the heating cooking done. Suryanuttan Chula is one of that type. Then applications. There are different applications of different cookers. Boiling type of cooking, then frying type of cooking, baking type of cooking, roasting type of cooking, and these all have different temperatures. Boiling type of cooking like rice, we have 100 degrees centigrade. For frying, we need 120 to 180. Baking is around 190. Roasting 200 and more than that. So whatever the box type cookers or advanced cookers or concentrating cookers, they operate at different temperatures. Like box type cookers generally preferred for low temperature cooking, like 100 degrees centigrade. Then concentrating cookers, they can reach up to 300 degree, 400 degree, depending upon their size and shape. Particularly when they are used for community cooking, the temperatures can reach around 400 degrees centigrade, depending upon their size and shape. Then advanced RTCs, there is again no limitations for getting the temperatures. All these cookers are called as intermediate temperatures cookers that are reaching beyond 100 degrees centigrade. Scheffler cookers, we know the steam is generated, superheated steam around 180 to 100 degrees centigrade, and that steam based cooking is done in Scheffler type of cookers. Then we have a primary source, a primary distribution of household and primary energy sources in India. If you see in rural areas, wood chips residues are still 46%, LPG 49%, other resources 3%. In urban areas, LPG is preferred as compared to other. If you see overall, LPG is 62% in urban, if you consider urban plus rural as an average. Other sources like natural gas, dung cake, kerosene, that are used for cooking also. So what are the attractive features of the solar cooker? Why it is important in today's era of decentralized energy solutions? Lot of people now working on solar cookers. They are trying to develop different designs. Different designs are available. Then different geometries, different shapes, as well as different types of cooking pots are being developed. So we have attractive features related to solar cookers, as these are what we can say it belongs to sustainable development goals. Gender equality, one of the major concern. There is no limitation, we can cook with woman and man. Then checks for deforestation, it will reduce deforestation. Then carbon credit for cooking is available. Even United Nations development programs funding different cooking programs all over the world, including India, Latin America, all African countries, all Arab countries. These types of incentives are available. Reduce household air pollution. Ujjwala scheme was launched by Government of India for that purpose only, to reduce the indoor pollution. But if we know the emission factors of different cooking fuels, particularly in last slide I show, there is a average 62% LPG is being used, but but we don't know what is happening with the LPG. Per kilogram of LPG when we burn, it gives 2.64 kilogram of carbon. So can we call LPG as a clean cooking? That is one of the questions. Then if we reduce the use of cow dung, we can use it as a manure in different agricultural purposes. So this can lead to increase the use of solar cookers in decentralized energy sector as well as household cooking and community cooking. Then what are the issues with the solar cookers? Problems in adaptability. That is the major issue. Why it is so? First is completion of cooking. Reliability due to unpredictable sunshine. If sunshine is unpredictable, then cooking cannot be completed and it will lead to incomplete cooking and people will lose the food. Then time taking schedule. Everyone is busy. Third one, cooking duration. How much energy is required for how much type of, how much quantity of food to be cooked. Then cooking methodology incompatible with traditional cooking practices. We as a researchers and scientists, we are not able to produce a holistic design that can cook all type of food: roasting, baking, frying, boiling type of food. So even the design is manufactured with holistic design can be manufactured. What happens? Then the other issues coming into picture: time scheduling, sunshine, all these things are coming into the picture. Then selection of type of cooker. If you are living in a multi-story building, you cannot use the parabola. There are limitations. Then cooking ergonomy. That is most important aspect. Women or men generally don't want to go into the sun for cooking. Then profitability and operational requirement, portability and operational requirements. Parabola can be shifted from one location to another location, but bulky cookers, if Suryanutan you can see, you can put it in one location, it cannot be transported from one location to another location. Schaeffler cooker, same issue. Then most important, how to rate and grade these cookers. Even though all types of designs are available in the market, the parameters available for testing the solar cookers are at low temperature only. We will see next slides. In Indian Prime Minister Narendra Modi ji sees big opportunity for solar cooktops in India, endorsed officially by flagging offset run Indian Oil patented solar Nutan Chulla, and they are now transferring the license to the different people for that purpose. So what is happening with this? All these types of solar cookers are available. Profitability and portability issues are there. Despite there are different parameters available for rating and grading of the solar cookers. Thermal performance parameters are used to evaluate thermal performances of different designs of solar cookers: box type, dish type, and panel type of solar cookers. TPP enables users, manufacturers, and a research community to identify cooker according to unique number. Again, we know physico-chemical cooking is a physico-chemical process, and it occurs over a fixed temperature. If we take rice as a food, which is largest food consumption in all over the world, rice is available in every part of the world. So pasteurization temperature of rice is 69 degrees centigrade. If a cooker is not reaching 69 degrees centigrade, then that rice cannot be cooked. So minimum temperature need to be required to be reached for starting the chemical process, cooking process for the rice is 69 degree. And simmering temperature, we know it starts from 85 to 95. 95 is the cooking temperature. So there are three different stages of cooking of rice. And again, cooking time type of design required, it depends upon what type of cooking we are doing. If we want to fry, if we want to roast, if we want to bake, the temperatures are different as I indicated. Due to this, finding thermal performance parameters is inequitable. For an unequitable performance evaluation and rating of different designs. For this purpose, we need different performance parameters. So what are these parameters available in the literature, published literature? First figure of merit, F1 and F2, developed by Professor Malik from IIT Delhi in 1987. These are available for box type of cooker, testing box type of cookers. Then cooking power, standardized cooking power developed by Professor Funk in 2000. And it is converted into American standards and ISO standards. Then, as we know, all solar collectors can be tested with thermal efficiency. Then we need a time for cooking. Again, there are three different times. Pasteurization temperature time is different. Simmering temperature time is different. Cooking temperature is different. Cooking time is different. So time is one of the parameter that we can consider. Then heat loss and heat loss factor and optical efficiency factor, concentration ratio, all these parameters need to be taken into account while testing performance of the solar cookers. And the parameter that we developed is called as cooker up to thermal ratio. It was invented in 2012 by our team, my professor. Then there are different objective parameters also. First is maximum achievable fluid temperature. What maximum temperature can cooker reach on a given day? What is the reference time? What is the time required for a given cooker for cooking? That may be boiling type, that may be baking type, that may be a roasting type. Then what is the heat retention ability? Heat retention time for that particular cooker. Why it is important? If sun goes out, if your cooker is not holding some heat, it cannot cook. So heat retention ability is one of the major parameter required. Then carbon mitigation potential and load limit. If a box cooker is there and it can cook only 2 kilo, we cannot load it as a 4 kilo. It will take a long time for cooking. So load limit of a cooker or loading capacity of a cooker is another important parameter. So what are the problems associated? We see what are the different test parameters. Now we see what are the problems. Lower boiling point of water limits its use as a test fluid. Water can reach only 95 degree or 100 degree centigrade for boiling type of cooking. And majority of cookers, box type of cookers can reach 100 degree only. Then applicability of the test for thermal performance parameters like F1, F2, then optical efficiency and heat loss factor, cooking power. All these parameters are developed only for boiling type of cooking. Its adaptability for high temperature not discussed yet. Then there is a lack of information about intermediate temperature cookers such as what is the highest temperature can cooker attain on a given day. How to rate the high temperature cookers. These issues are still pending and the solution has been given by our team. We will see it step by step. The issues related to existing existing thermal performance parameters and their stability at high temperatures. Then ability of the test parameters to compare different designs. If a box cooker is there are different designs of box cooker or there are different designs of parabolic cooker. How we can compare the performance using a single parameter is an issue. Then again, quantification of test load. Whatever the test standards that we show, figures of merit, heat loss and optical efficiency factors for dish cookers, cooking power, different standards given different taste loads, different quantity of taste load to be used in the cookers. According to first figure of merit, that is the box cooker standards, they are suggesting that the figure of merit followed by Bureau of Indian Standards, they suggest 8 kilogram of load per square meter aperture area of the cooker. Then cooking power standards regarded as a ISO standard, they are suggesting 7 kilogram of load, 7 kilogram of water as a test load. Then we developed a core cooker optothermal ratio. We are taking load as a 2.5 kilogram of water according to different conditions. That is why quantification of test load is important in solar cookers. Why it is important? The higher the load, the lower reaching the temperature limits are there for a given cooker. So one person is using 4 kilogram of water, another person is using 8 kilogram of water, heat transfer characteristics definitely changes. And the same cooker can give different parameters for a single cooker. That is why uniform loading of a cooker is important. It justifies appropriate quantification of the test load for a given cooker while measuring and calculating the test parameters. Then if water is not used, then what is the solution for high temperature cookers? You need to use alternative fluids, maybe oil, maybe engine oil, maybe cooking oils. Okay, so but what happens with this? If a coconut oil is manufactured in India and same coconut oil is manufactured in Chile, qualitatively there are impurities, maybe, and that is why this type of fluids can induce errors in the parameters. For that purpose, we need a fluids that have stable thermodynamic properties at low temperature as well as high temperature. It should have the specific heat capacity less than water so that resolution can be visible, and the fluid density should be near the water so that it can maintain the density throughout the experimentation. So I discussed this according to core, which is we call it as a cooker optothermal ratio. We suggested load to be taken in heat capacities, not in kilograms. So according to core standards, 10.46 kilojoule per degree centigrade per meter square aperture area is the load suggested, and it is named as specific thermal test load, SSTL. Why it is taken? Initially the load is calculated in terms of water, heat capacity of water, 2.5 kilogram of water into heat capacity. It goes to around 10,500 per meters kilojoule per meter square aperture area. Then we kept the heat capacity same and reported two new test fluids which have stable thermodynamic properties at intermediate temperatures. First is diethylene glycol, second one is glycerin. These two fluids are monomolecular fluids. They can be manufactured anywhere in the world, and they have stable thermodynamic properties at low as well as high temperature. But later we found diethylene glycol has some toxicity, so we dropped diethylene glycol and we concentrated on glycerin as a test fluid for testing different designs of solar cookers at low as well as high temperatures. Then what are the limitations, or what we can say, some comments about figures of merit? Now researchers, what is happening with the test parameters? We are discussing about the test parameters for the cookers. These figures of merit are being used for hybrid cookers according to test procedure given by Bureau of Indian Standards and Malik sir. They don't suggested use of F1 and F2 figures of merit for hybrid cookers. Now cookers are making with thermal storage, they are making with some electrical backup, some another type of system, and they are being tested with the figures of merit, which is giving a wrong quantification of the number for a given cooker. Because whatever the hybridization we are doing, that is not taken into account while testing. Same is the case for dish cookers. Dish cookers are being tested with no load test. That is the figure of merit one suggested by Professor Malik and adopted by the Bureau of Indian Standards. It is a no load test, that is, it is to be taken with a bare absorber plate of the box cooker. And despite that, dish cookers are being tested with the no load test, F1, F2, F1. Again, it is misguiding the research community. Because what is happening with the, in case of, if you are doing the similar test, no load test for dish cookers, the temperatures, because it is a bright spot at the bottom, and the temperatures are not uniform. Which temperature you are going to take? If you are putting a cooking pot, temperatures are different at different level. Top may be high, low may be, lower temperature may be high, but side temperatures are different. It induces error in the heat loss and optical efficiency factor for dish cookers. You can see some figures, issues with the cooking power and thermal efficiency. So these are the two plots we can see. With this, there are three cookers operating at different temperatures, and lines are crossing. Here we can see the lines are crossing. So which cooker is best? Which cooker is bad? We don't know. Similar is the case for efficiency. If you see the linear feet of efficiency, it goes like this one. Rice at 25 degrees centigrade, rice at 95 degrees centigrade. Temperatures are different, efficiency is different. We have to consider maximum and minimum efficiency, or maximum or minimum power for a given cooker. So how to do the rating, how to standardize the cookers, how to guide manufacturers for that purpose. So what are the problems associated with the solar cooking power that is accepted as a global standard by International Energy, ISO? The cooking power is defined at temperature difference of TD, ambient temperature plus 50 degrees centigrade. What happens if a parabolic dish type of cooker is operating and it is reaching 200 degrees centigrade? Shall we decide a power at TD, temperature difference of TD? No. What is happening with this? Ambient, again, they are recommending the ambient temperature range between 20 to 35. But now globally temperatures are going beyond 50 degrees centigrade. So how to satisfy this condition? Yeah. So there are different limitations for the cooking power. On this we write one article recently in Sustainable Energy Technologies. You can refer that. Because of time limitation, I am moving fast. Energy analysis, I said we have to take maximum and minimum efficiency for a given cooker or a given thermal collector. And because they are mainly efficiency mainly dependent upon the temperatures. At low temperature, high efficiency, high temperature, low efficiency, that we know. So it cannot be used as thermal performance parameter for the cooker efficiency. Same as F1, F2, figures of merit, then heat loss and optical efficiency factor, cooking power, all are defined at low temperature. For that purpose, it is causing non-uniform, inconsistent use of the test procedures. for determining the TPPs, resulting in anomalies in solar cookers, and subsequent rating and grading of the solar cookers and standardization. For that purpose, we have defined a cooker optothermal ratio. It is a ratio of optical efficiency factor to the specific heat loss factor. F dash eta naught divided by F dash UL by C. F dash is the heat exchange efficiency factor. It is a single step process. It has been developed. It is based on a single step procedure. You can use any fluid, water, glycerin, glycol, oil, and you can test a cooker. But generally, that as indicated to you, glycerin is preferred as a monomolecular test fluid, which is having boiling point of 290 degrees centigrade. And with that, anyone can test any type of solar cooker that reaching intermediate temperature of 120 to 300 degrees centigrade. So what are the characteristics of the core? It depends, because here you can see if C is coming into the picture. C is the concentration ratio. Once the concentration ratio coming into the picture, you can use this parameter for any type of solar cookers. Depending upon core, we define different objective parameters: maximum achievable fluid temperature, then reference time, then heat retention time, then levelized cost of cooking meals, and carbon mitigation potential. Based upon core, you can test and evaluate cooker holistically, because it is giving all type of parameters. It is giving maximum achievable fluid temperature theoretically, and you can validate it experimentally. Same is the case for levelized cost. Same is the case for carbon mitigation potential. All these parameters uses core as a test parameter for the solar cookers. These are the sample values of core for different designs of solar cookers since 2012 until till today. In last, we can say 12 years, 50 different designs of solar cooker has been tested with the core, and they have the unique number for a given cooker. I am giving the sample only for 2-3 cases. Box cooker, figure of merit 1 given as a 0.12. Funnel cooker, we cannot test funnel cookers with F1, F2. Figures of merit are not applicable. Concentrating cookers, figures of merit are not applicable. Then second figure of merit for box cooker is more than 0.25. For funnel cooker and concentrating cooker, F1, F2 is not applicable. Then standardized cooking power is applicable to all cookers, but you can see the values, large variation in the values there. Then cooker optothermal ratio for different designs. For box cooker, one of the box cookers, it was 0.148. Funnel cooker, it was 157, and another for concentrating cooker, it was 0.30. So all types of solar cookers can be tested with the core as a parameter. Then based upon core, we developed effective concentration ratio by thermal method. Effective concentration ratio is a ratio of core with reflector and core without reflector. And typical values for 3-4 cookers that we developed as a concentration ratio, we can see effective concentration ratio for box cookers. Then for square parabolic dish, satellite dish, and Parvati cooker. These are 4 cookers that we tested with, because this is a recent parameter that we developed based on core. It gives it characterizes a real time performance of cooker in terms of concentration ratio. Because once we get a core for a given design of cooker, you can test it without reflector. It will give another value. And the ratio of these two, core by core, is a concentration ratio. It is evaluated experimentally. It is an experimental concentration ratio, not theoretically. It is not a geometrical concentration ratio. So these are our works enabling. This was the first core reported in applied energy in 2012. Then this is the work for testing solar cookers working at intermediate temperatures using core. It was in 2018. Then ensuring completion of solar cooking process under unexpected reduction in solar irradiance. It was published in 2019. Then determination of experimental thermal concentration, effective concentration ratio, 2018 again. Enabling open sun cooling test base effective concentration ratio for concentrating cookers in 2021. Then we applied core to the thermal storage of cooker, storage type of cookers in 2022. It was published in energy storage. Then core is applied to dual performance cookers, cooker cum dryer. It was published in 2013, 20th last year. And then we applied core for cooker cum water heater in 2023. So core is a generalized test parameter, and core based thermal process test procedure is a generalized test procedure for solar cookers, and that can be used for testing different designs of solar cooker. So what is the way forward? The ultimate aim is to reduce dependence on fossil fuels with the help of solar energy, with solar cookers, to enhance energy security and reduce indoor pollution. TPP based evaluation of solar cookers supports above indicated motives. TPP based thermal performance parameter based rating will help researchers, designers, manufacturers, and end user to gain insights into its usefulness, suitability, applicability of different test procedures, and you can compare it with the generalized test procedure based on core. It will help manufacturers to develop effective designs of solar cookers. So this is the way forward, future works that we are planning now, to identify and find new pathways for core for advancement in future existing designs and hybrid cookers. Now we are going to apply core for hybrid cookers, maybe with electrical backup and some other hybridization techniques like heat transfer fluid based cookers. Also, we are trying it for Schaefflers. Then to enhance the use of core to the research community, product designers for appropriate rating and grading of solar cookers, to develop a standards based on core. Thank you. If you have questions, I'm open.
Hello. Do you have any cost benefit analysis of this?
Yes, the levelized, we are developing a levelized cost based on core. As we indicated, here is a parameter. We named this as a, here, levelized cost of solar cooked meals. It is a ratio, we can, it is a ratio of product of number of sunny days into cooking time divided by reference time. Reference time is developed based on core.
But what about the initial cost of this and the running cost of this system?
No, we can do a reverse engineering. You can consider a value of core. Suppose you considering value of core as a 0.20. You can do a reverse engineering and you can develop a cooker.
Because we want to see whether it is really cost effective over the conventional available.
Yeah, in our paper in the energy storage, we have already given all these parameters in the paper.
And the parameter that you have shown, this COR,
Yeah.
but I don't see any parameter for fluid over there.
Yeah, no, no. The thing is that heat exchange efficiency factor is in the definition of core. Core is a ratio of F dash eta naught optical efficiency into heat exchange factor divided by F dash UL by C. So heat exchange factor, heat exchange efficiency factor coming into the picture there.
Okay, okay. It is involved.
Yes, it is already involved.
Okay, thank you, thank you.
Yes, sir. Yeah, yeah. Yeah, yeah. No, we are discussing about issues with the cooking power and thermal efficiency. You can see here there are two lines are crossing for a single cooker and working at different temperature. The two lines are crossing. So if two lines are crossing, how to rate the cooker? Which is the best, or which is the appropriate cooking power for that cooker, or what is the appropriate efficiency for that cooker? How end user or manufacturer can decide? If you assume a value of efficiency or cooking power initially and you go reverse engineering, it is not possible to develop a cooker. With the core, it is possible. Yeah. Yes. Where in the equation of core, we are core basically depends upon core is derived from SWB equation, Hotel Wheeler Bliss equation. Hotel Wheeler Bliss equation, we have the G value there, GT value there. Yes. Yes, exactly. Exactly. The temperature difference divided by G. Yes, we did the same thing. It is, we are not calling it as an efficiency. Why it is not efficiency? Even we consider a 1 minute period. When we do the heating process, we don't know which, at what moment the efficiency being calculated. Even we call it is instantaneous efficiency. We are testing solar cookers from plus minus 2 hours of solar noon, 120 minutes of solar noon. Plus that is total duration is 4 hours. From 10 to 2, 10 to 2. Thank you. Hello, back.
Sir, what are your observation for different fluids?
Different fluids related to what is the, as I said, we should use monomolecular fluids like glycerin, glycol, but glycol, as I said, it is when it reaches high temperature, it produces some toxic smoke. So we dropped glycol, but glycerin is working as a good fluid. But if we use any type of oil, cooking oil, suppose like sunflower oil or some coconut oil or olive oil, the it depends that its characteristic, fluid dynamic characteristic depend upon the manufacturer. They may all type of cooking oils have temperature, boiling temperature around 240, 230, 240. But impurities or quality depends upon the manufacturers, and that cause a problem in rating and grading.
So working fluid is affecting the core parameter. Is it so?
It is not like that. It induces errors in the calculation of core.
How to mitigate this?
That is what we said. We should use monomolecular test fluids like glycerin. You can use another one. Glycerin is not unique one. You can use another one. Glycerin, we are preferring glycerin because it having stable fluid dynamic characteristics from 40 degree to 250 degree centigrade. We shown it is through TGA curve, DSA TGA analysis in our papers. Thank you, sir.
Thank you, sir, for such enriching and knowledgeable presentation. Before we move to the second keynote talk of the day, I would like to introduce our second keynote speaker, Dr. Pallab Sinha Mahapatra, IIT Madras. The topic of his keynote talk is collective dynamics in active systems. हाँ सर, चेयर कौन से हैं? I would like Dr. Anil Kumar from DTU to felicitate our speaker, Dr. Pallab Singh Mahapatra, with a sapling. Yes. Yes. Professor Pallab Singh Mahapatra is an associate professor in the Department of Mechanical Engineering, IIT Madras. He received his PhD and BE from the Department of Mechanical Engineering, Jadavpur University in 2014 and 2007 respectively. He also had postdoctoral encompasses interfacial flows, wettability engineering, collective dynamics, and energy systems. He is a Dr. V. Ganesan Faculty Fellow and the recipient of the ISEES Young Scientist Award, SERB Early Career Research Award, Institute Research and Development Award, etc.
Thank you. Thank you for the nice introductions and thank you for inviting me here. Good afternoon, and I will talk about slightly different topics. It's called collective dynamics in active systems. So I think the video was not playing now. So we have seen collective behaviors in nature, particularly when there is a school of fish or flock of birds moving around. So we try to understand the physics behind this nature of the flow. So this is a fluid mechanics problem as well as we see it from a physics perspective. So here I will talk about from a fluid mechanics how we can solve it and how we can understand the physics behind these collective behaviors. So before that, I will briefly talk about our research areas as was mentioned before. So we worked on surface engineering a lot. We create micro nano engineered surfaces, apply it for different applications. Wettability patterning, we use it for droplet manipulations, paper-based microfluidics. We use it for different heat transfer applications. We create heat pipes, vapor chamber like devices where we extensively use condensation boiling on these modified surfaces. We also do particle liquid interaction based fundamental studies where a particle impacting on a liquid, how it moves and so on. We worked on collective dynamics, mixing, segregation, spread-applied dynamics, crowd dynamics. So these are all part of collective behaviors, which I will talk about today. Also another area which we recently started is 3D cell cultures, drug delivery, and cell patterning on modified surfaces. These are all different types of multi-phase problems, and we are interested in all these multi-phase systems. So as I was talking about collective behaviors, so when we talked about collective behaviors, these are basically coordinated movements of organisms in different length scales, starting from swarm of bacteria to the school of bees to flock of birds. And this generally we observe in the nature have different reasons. One, like few possible reasons could be to improve the foraging efficiency, to dilute the risk of predation, to promote predator confusion, or to reduce energy consumption for locomotion. So when there is, we can think it in this way, as a monopole worker, we can move anywhere we want. But when we are in a crowd, we have to move in the crowd. So that's why this crowd dynamics is slightly different than a individual movement. So similarly, when a fish is moving in a tank or in a river, it can move anywhere. But when it's moving in a flock, it will align to the neighbors and it will move along the flock. So just to start with few introductions and few jargons which we were talking about. Now we talked about active agents. So active agents means these are continuously consuming energy and it moves. So it can be a natural system like fish, bird or something, or it can be a artificial system like a micro robots. So which can also work like an active agents and it can move. These are of different length scales, starting from microscopic to macroscopic, as I said before, from a bacterial swarm to flock of birds. And we have different applications for collective behavior studies for living systems, biomedical. We have the drug delivery systems. In micro robots are used for microsurgery. Granular mixings are generally used in pharmaceuticals. In microfluidics, we use it for transport, mixing, separations, and so on. In energy harvesting, particularly piezoelectricity, in the robotic swarms are used in military applications. So there are a lot of other applications where everything is active. But in some situations, we have both active and passive systems. So when we talked about the passive system, this means they don't have any self-propelled force. So it will not move by itself. It can move by the presence of other active agents, but it will not move directly. So that's why there are systems where it's a mix of both active and passive particles or passive agents. So there are systems like active passive colloid interactions, like in the food industry for homogeneous mixing, using some robots we can use it. For biomedicals, like for targeted drug delivery, cargo delivery, for pharmaceutical industry, granular mixing, sorting and separations are few examples of that. So when we talked about all these systems, there are few system characteristics we have to talk about. One is the cell propulsions, how these agents are moving. And when these agents are moving, to show a collective behavior, it has to align with the neighbors. So there will be alignment with the neighbors, and there can be attraction among the constituents, or it can have some repulsion. It can have some resistance against the propulsions, and mostly in nature these are stochastic. So there are stochasticity involved. It will not align perfectly. So there will be some noise. So when we talked about a system behavior, we will see collective motions like a swarming. There can be phase separations. If there are differences in speed or differences in sizes, we can see some phase separations among the active systems. There can be localized cluster formations. There can be segregations or aggregations, or we can sometimes see mixing. There are different models available. One classical model is a Visek model. Then there are active Brownian particle models or APP models when we are talking about a Brownian dynamics. There are run and tumble models, particularly when we talked about bacterial motions, we want to model it, then we generally use a run and tumble model. So if the bacteria run for some time, then it tumbled and then it's run again and so on. There are active nematics, there are tone and two model, social force model, etc. So the equations for mimicking the system depends on what type of systems we are trying to mimic. So what we're trying to understand or characterize. Based on that, we can choose our models. So we worked on different types of model systems. So for same species mixing, segregations, then predator-prey dynamics. So here I will mostly talk about active matter and in macrobiology, predator-prey dynamics, but there are collective behavior as such, also includes behavioral biology, microbiology, social dynamics, swarm robotics, and crowd dynamics. So we worked a little bit on the crowd dynamics, but today I will not talk about the crowd dynamics. But if you're interested, we are happy to. I'll be happy to discuss about the crowds. So regarding the model, mostly I will talk about numerical modeling here. The experimental part I will not show today. So this is a modified versions of the VSEC model. So where there are two states, because this is a generic model, so we can include both living as well as dead system, like active and passive systems. So this parameter Jai will take care of that. So the main forces are pairwise suppression force, local alignment force, propulsion force, and attraction force. And we integrated this using a velocity Varley algorithm, something similar to what we generally use in molecular dynamics. So this mainly we talked about active matters and predator-prey dynamics. I will talk about this predator-prey dynamics in detail afterwards. So regarding the propulsion force, when we have a single active system, then it will have only cruising state. But if we have a, let's say, a predator in the system, then it will have both cruising state and escape state for the prey, and for the predator it will have a pursuit state. That means the predator will chase the prey, and then due to that the prey will escape. So it will have a different velocity compared to when it is in cruising state. So this is a cartoon of that forces. So the propulsion forces. So mainly, if you can see that, it depends on the activity parameter beta. And there is a Rayleigh friction term, so that there will be no unbounded accelerations of the system. So this is m times beta minus alpha velocity square, something like that. And it is aligned towards the velocity where this particle is moving. And now if it is a pursuit state for the predator, it will chase the prey. So it will align towards the prey. If it is a escape state for the prey, it will try to move away from the predator. If we remember this, I think we'll be able to discuss this in further. So now there can be an attraction force. This is not important when we talked about only active system. This is important for a prey group, for an isolated prey to come into the prey group. So, let's say a prey which is becoming isolated in some situations, so it will come back to the prey group. That's what these forces, form of the forces has been taken from different experimental papers. So they observed this in the nature, and based on that, these forms has been taken. There can be pairwise separation force. This is particularly important for a biological system, so that they will not overlap. It's like a soft disk. So if they overlap, there will be a repulsion force. And this will work only when there will be a possible overlap. Otherwise, this will not work. So it's like a pairwise interaction. If it overlaps, then there will be a repulsion force. Then the alignment force is the sole reason of this collective motion. This alignment force is like this particle is trying to align with the neighbors, and this has been taken. It's like something similar to this form of this alignment force is something similar to our drag force. If you see the force terms, it has a coefficient which is CV times the diameter and times the velocity, relative velocity. So when we talked about the liquid, even without considering the explicit form of the liquids, and by the way, this is true when we have a dense system. If the system is very sparse, this form may not work exactly. So we have to modify this form if it is a very sparse. But if it is a dense system, this works quite well. And there we have a noise term. So when this particle is trying to align with the neighbor, it may not align exactly. So it may have some noise. So that's why we have considered a angular Gaussian noise with a zero mean and finite variance. And we have a weight parameter by which we have calculated the velocity of the surrounding. As you can see the form, I will not go into the detail of it. So we have taken a kernel how it can be taken, how the liquid velocity can be considered from the fluid velocity, from the particle velocity. If it is, this is true only when it is a very dense system. So the liquid velocity is very small. So now if we try to understand what are the control parameter it is, because there are a lot of variables. If we try to understand what parameter we can control, so that there will be only one or two parameters which we can modify and try to see the overall behavior. So first, if we consider, if we compare alignment force with the self-propel force for a single particle, we can write a equation like this. And now if we do a scale of the slip velocity, so the velocities can be scaled as m beta by dCV, and finally we get a scale parameter. This is like an alignment force to the inertial force. So this will give a relative importance of the alignment compared to the inertia of the particles. So this parameter chi we are varying in our simulations, and we are trying to see whether a completely random system can be bring to a collective motions. So that's what we started with. Say for example, for a very low chi value, you can see it's like a thermal motions or a Brownian motions initially. But when we increase the chi, you can see the second panel where it shows some rotating behavior. It's called milling. So this has been observed, this type of behavior has been observed for bacteria when they are confined in a system. So if you all these simulations has been done in a confined system. So there is a boundary. So due to this effect of the boundary, it started rotating. So you can see this, we can have a single mill or a double mill depending, this which is a very unstable situations, that is 3.6 into 10 power 3. In that regime, we have a unstable system which will show a double mill. And if we increase chi further, it will align so much that it will just oscillate. It is like a vibratory motions in the system. So here mainly we have considered the self-propel force. There is a particle-particle repulsion force and the alignment force, and the form of these forces the way I have discussed before. So this is what we have seen. These are the particle. This color we have given the same particle, all are active. Just to see understand how it is mixing within it, we have given a blue and pink color. And these are the velocity vectors drawn on top of it. So you can see initially it is all random motions when the chi is very small, and slowly it goes into a milling motions, and finally it is just oscillatory motions within the wall. So after understanding this, that it is possible to create a system where it is a kind of Brownian to a oscillatory systems with a milling in the transition. We have done a little more detail of that. I am not going into that. So we want to see how the behavior will change if we have a passive particles. So whether it will be able to mix because of these active particles, or it will show some other behavior. So in this system, this is a monodisperse system. So we did polydisperse system also, but here I am showing only the monodisperse cases where this gray are the passive particles, yellow are active particles, and these are the wall. So this is also a confined system, and these are randomly distributed, and these are the scaling parameters, everything what I have shown before, the similar chi parameter, that so only one parameter we will change, and we will see how the behavior changes. So what we have observed is something similar to before. If we increase chi, so it will coordinate well, and it will show a collective motion. So from a random motions initially at a lower chi to a very coordinating circular motions we will observe at a higher chi. So at low chi we will have a random motion phase, and higher chi we will have a milling motions, and at the very high chi we will have a kind of a oscillatory motions. So the behavior is almost similar, although the values will change at a critical chi where it will transitions from a random motions to a milling motions. But otherwise the behavior is almost similar, whether it is a pure active systems or a active or passive system, active and passive mixed system. So then try to understand whether we can see the phase transitions. Can we quantify the phase transitions? So we created a viscous dissipation based system from a Lagrangian based system to we convert into a Eulerian system and calculated the viscous dissipations. A sense of viscous dissipation because we know the velocities. So this is an established way of identifying the dissipation rate with time. So this is not something we have done for the first time. There are papers before, so we have taken from there. What we have identified that this random motion to a milling motions changes when there is a critical chi, and we call it as a chi c. So if it is less than that chi c, it will be a random motions. If it is more than that, it will be a milling motions. And this is a first order transition. So to identify whether it's a first order transition or a second order transitions, we have to run simulations with a varying chi. So for example, we go into the forward directions by increasing the chi, and then we will come back by decreasing the chi in the different simulations in a steady state cases. So you will see a loop as you can see in the inset. So if you can see a loop in the or a hysteresis in the in your control parameter or a order parameter graph, then this is a first order transitions which has been reported earlier, Chate in 2008, that you can identify that as a first order transition. So after doing this, we try to see, okay, we have added some active particles and with different passive particles, can we change it? Can we change the packing fractions of the active particles, and whether that has a implications of the overall transition? And it has. So if we decrease the active particle concentrations, your critical chi that depends, that changes the random motion to the milling motion, that goes up. And if we decrease it, so overall effective alignment also decreases, and we can plot that chi c based on the effective rho. Okay. So now after understanding this as a active systems, we thought of understand it, what will happen to the behavior when there is a predator, because now the system will be much more complex because we have all active but of different types. One can consume the other, or even if we consider a non-consuming predator, it can kill it. So it will be initially all active, but it will become passive when it kills. And we are mimicking situations where it is a continuous attack or a sustained attack. It's not a single attack, but a sustained attack by the predator. So if you see this video, this is a fish school where there is a shark, and when it is moving, it is avoiding the this fish school is avoiding the shark. So this motivates us to do the simulations. Can we mimic it? Can we see whether our prey group will avoid the predator and can move away from there? So this collective behavior, as I was telling earlier, this evolved naturally over time for to optimal against the predation. So that could be one reason why we see collective behaviors, and to model it accurately, we have to know the behavior, the underlying mechanisms involved in such situations. So we can, if we understand it properly, we can possibly use it for swarm robotics, which can be used for military and disaster rescue applications, or for a crowd dynamics, like to predict stampede and other things. So these are few examples. Collective actions also used by ants and other insects for different biomimetic situations. For example, this fire ant rafts on the water, they collectively come together and create the rafts and crosses the rivers. So in these cases, as I said, it is slightly more complicated because we have a predator. So there are different zones of attacks, zones of identifications of the prey. So for a predator, there is a zone of killing surrounding the predator, and it has a zone of detection on which it can detect the prey. It cannot detect the prey everywhere in the domain. For the prey, similarly, prey can also detect a predator. Prey has a alignment zone on which it will align with the neighbors. It will not align to very far away prey. It will align only up to a zone. And to mimic it as close to the natural system, it will not have a 360-degree vision, but will have a blind angle. So we have given a blind angle of 60-degree here, but it's a variable. We change it for different angles. So this is our basic algorithm. First it will detect, then it will select the target, it will pursue it. If the target is within the kill zone, then it will be able to kill, then it will have a satisfaction zone, it will again go back and it will do the same thing. If it not able to do that, then and the maximum time which is given for the predator to search for it is over, then it will have a refocus state, it will wait for some time and then again start that process. So that's how it has been modeled. So this is a video for a non-consuming predator. So it has killed, so now it is waiting, then it's pursued. As you can see, there is a cyan color prey which is in its vicinity. So it will change it to red now when it will be able to kill it. So then again it will start, and this is the predation cycle which I talked about before. So, but this is for a single predator in a closed domain. So few of the behavior which you are seeing in a closed domain may not applicable for a wild, because it's an open domain, and so this behavior may not be observed. But this overall behavior is more or less observed in the nature. Now, as I said, there are confinement effect, so that's why you can see that it is coming back. The prey are coming back. It has to come back, so it cannot go around because it's not an open domain. So, but there is a predator influence. So with the increase in chi, it will be more aligned. The prey will be more aligned to each other, so it will be able to to evade the predator. Yeah. So now this is what we have observed. We have observed behavior like split and join. The prey will split and then join back again. It has shown the fountain behavior and so on, which has been observed before in nature, particularly in experiments. So then we have defined a order parameter, which is a velocity based order parameter, and we have seen that with the increase of chi, it is more ordered and it can the overall killing rate changes based on the increase of chi. I will discuss this slightly more detail afterwards. So now, how a predator can select a prey? Till now, in a single predator systems, we have implemented only the nearest prey it will select and it will kill, which is more common in nature. But there are three possibilities which can happen. One is the nearest prey. The predator will select the nearest prey, or it will select the isolated prey, or it will select a central prey. In the nearest prey group, it will select only the central prey, and it will try to break the prey group. What you are seeing in that video of the shark moving in the feces. So it is selecting the center of it and it's trying to break it into a smaller groups. Particularly the tactics the predator used when they hunt in a group. For a group hunting, this is a very common tactics. So few of the predator will try to break the groups into smaller groups so that the other members can attack the prey and have more successful killing. So we have tried to implement all these rules. We have done nearest prey, and we have done a two predator system where individually it is nearest or central isolated, or there is a probability it will select one of these. So we have done situations like this. So now on the right side you see a schematic which has been published by Paris et al. In 2002 in Biological Bulletin, where they from the nature they identified that there are different types of behavior. One is splitting, one is herding. Say, for example, splitting, as you can see in our simulations here, the two predators which are non-coordinating. So they are not coordinating each other, they are just attacking the prey group, and it is able to split that. And then sometimes it is showing a herding behavior where both the predator is attacking the same prey group, or it can have a avoiding phenomena where the predator, it is like a single predator attack. So these are two isolated groups and the predator is attacking each of these. Now if you try to understand it, what is happening here, that this figure A here, this is the splitting phenomena. So these are positions of the predator with time. This all this for the predator 1, this for the predator 2, and this is the position of the central of mass of the prey group. So initially, when this is 1, when they are attacking from the opposite side, so this is here, then slowly it breaks and it goes into two different, it becomes a isolated group. That is what you are seeing in avoiding situations. So it is splitting it is able to split the group, and it can have a separate isolated groups, and each predator will attack each of these. And we have not given any, as I said, these are all individual predators. It is choosing their randomly with a probability we have given that it will choose whatever, either the nearest or nearest central type of thing. And we are simulating a danio fish, which is a variant of a zebrafish. These are the mass and blind spot for that fish. So it has a 60-degree blind spot. So we mimicked that. We have tried to take all the parameters, like actual parameters that is possible. Now, if you try to understand what is happening when there are asynchronous spray, and particularly for the sustained attack, if we define a order parameter, this order parameter, when the flock is polarized, that means it is having the whole group is moving into a particular direction. That is a point A. So there, when the polarization parameter is close to 1, that means this psi parameter is close to 1, that means it is highly polarized, it will move in only in one direction. When it's close to 0, that means it will move randomly in different directions. That normally happen when the prey group in a confusion state. So if two prey groups collide each other, then they will be always in a confusion state, they don't know where to move. So that is what we have observed here by using this order parameter. It started with a high, this is a part of the simulations where it is in a polarized state, it is coming down in a confusion state, then slowly it will recover in a recovery zone, and then it will go back to its polarized zone again, which we are seeing here in the different insets. Because of the time, I am not going into detail, but we can discuss it afterwards. And these are the velocity, corresponding velocity of that state. So the velocity we are seeing on the secondary y-axis and the polarizations on the primary y-axis. We have tried to develop a simple scale model, like with an assumption that a well-distributed but a compact prey flock and prey are alert, that is, it is in a escape state, and this scaling is done for a very small temporal window, so that the surrounding velocity of the liquid is more or less constant, so that will not affect it. And if we do the scaling, we can more or less match whatever the velocity of the prey group we are getting in the numerical. And all these numerical simulations has been done at least 50 times to understand the stochasticity in the simulation. So that's why you have a error bar. So this has been 50 to 100 times depending on what parameter we are choosing. So these are long simulations, very, very long simulations. So then what we have seen that with the increase of chi, the overall velocity of the prey decreases. So this superfluous coordination. So as chi is high, that means the coordination is very high. So these superfluous coordinations among the prey actually detrimental. It will decrease the overall prey velocity. So it will decrease the prey velocity because now it tries to move in a group. So that we will see in the next slide, that in the overall number of live prey decreases when the chi is very high in the system. So that means our predator is able to kill more if you have a very high predation, like a very high coordination among the prey group. So I think I will take just one thing. Now, if we try to compare what will happen when there is a single predator compared to a multiple predator. So we have done only up to 2 predators, because more than 2 is slightly more complicated. It is taking more time. So we have not done that yet. But what we have observed is it's not additive. So the number of killing done, or the time taken to kill individual prey by the predator when it is it is a single predator compared to a 2 predator, it's not additive. It is more than 2. So that is one of the key observations from our study. Now this is very important, particularly for a group hunting. So that's why generally group hunting is preferable in the wild rather than a single hunting, because single hunting the failure rate is very, very high. So that's why few of the wolves and dogs hunt together. So it can detect or it can mimic few of the things which we observe in the nature. So predation effect are highly non-additive in nature, even in the absence of explicit predator coordinations. So currently we are working on the coordinating predators, which is slightly more complex, particularly the probability and the stochasticity involved in it. So in summary, only for these flock groups, so we have observed that the dynamics of the flock response are quite different in case of attacks by multiple predators. Multiple predators bring in new observations in the system whose dynamics are not well researched, particularly these 2 predator systems. There are only few works, and numerically probably we are the first groups who did in detail study in that. And the effect of predations is non-additive by nature, even in the absence of explicit coordinations. And the superfluous alignment among prey can lead to reduced speed, thereby resulting in higher prey mortality, especially in the case of sustained predator attacks. So for the future, it is more interesting to see if we have a coordinating predators with a sustained attack, or some delayed attack, how, for the different predators, how it will be. So that's what we are currently working on. And this, the acknowledgements, my collaborators and my students, some funding agencies, and thank you.
Thanks for some wonderful and insightful presentation on this collective dynamic. Any questions?
Well, Professor Mahapatra, it's an excellent presentation. Now, I would like to understand, in some cases, the entities are moving in a completely liquid medium, for example, water. In some cases, they may move in air. So how your simulation can take up all those different mediums?
It cannot.
And account?
No, it cannot. There are no single model yet. So as I said, there are VSEC model. VSEC alignment, like overall alignment rules, yes, it will work up to a certain level. But as there are a lot of noise involved, so it will not align properly. There are other, so currently our noise has been given only in the alignment term. But there can be noise itself in the velocity or in the cell propulsion, because there can be a polydispersity in the group, and with the air and the liquid medium is completely different, because in a liquid it has a resistance. Right. In a air, it don't have a resistance as such, so it can move anywhere, even though we see collective behavior in the air. So our model is now applicable only for the aqueous system, so it will not directly for the air system yet. And also another thing, as I said, few of the assumptions is true when it is a dense system.
particularly that liquid velocity. So ideally, we need a Eulerian-Lagrangian coupling.
Right.
So which we have not done, because this itself is taking a lot of time to simulate. As there are noise, as I said, we have to do 50 to 100 simulations in some cases.
Or
So-
alternatively, you can opt for lattice Boltzmann technique.
Lattice Boltzmann, there are few people who have tried. There are other approaches like you can, instead of doing this, is kind of a underdamped Langevin system. So we can use a overdamped Langevin system. You don't consider the mass of it, and you consider all the particles. Then it might be possible, like something similar to a Brownian system.
Right.
Yeah. So
Yeah, your this order parameter chi. So what is what does it physically signify?
So physically, it means how your alignment strength is compared to the inertial term, compared to the inertia of the system or the particle. So that's how this chi is changing. But that is not a order parameter. That's a control parameter. So we are changing the chi and we try to see how our alignment is changing. So order parameter is here a psi. So that's like a velocity based order parameter. Say, for example, here. So psi is the order parameter. So that depends on the velocity. It depends on how many living prey in the unique living prey on the neighbor. So based on that, it will move. So that's the order parameter. So from there will be this is like a polarization parameter, whether everything is moving in the same directions or it is moving in different directions. So that gives a order of it. Like there are different types of order parameter we can define. This is one way of defining it. You can define a rotational order parameter, particularly in the milling type of system. We can define that. But for a open domain, or by the way, this is a periodic domain. So we have done a periodic domain here because in nature it cannot be closed. So all these two predator systems are in a periodic domain. We have done simulations for an open domain also, but that takes a lot of time.
Yeah.
Like simulations, your array size will increase when it is going up and so on. So that is even more.
Yeah, I understand it. So my last question is, being a mechanical engineer,
Yeah.
so what how do you correlate this research into your mechanical domain? What is the application?
Applications, we try to connect different applications which I was telling, but which is not correct. We tell directly. One is this predator system. Is this type of collective behaviors is mostly comes from the physics. When I started this, I was interacting with faculties in physics and I started this. Then somehow I got a student who is interested in the physics, and now he is collaborating with others who are in physics. So they are more interested on the fundamental behavioral or ecological system rather than directly an application. But there are applications, say for example, there are information transfer, which I have not shown here. We did some analytics of that. So, for example, a predator, when a prey group seeing it, these informations, because this is like a visual cue. So they first prey or few who are in the vicinity of that, say for example, here. So the prey can identify a predator. So that information will go back to all the groups. So this is a information propagations. These information propagations is very important for news propagations, for fake news propagations, for swarm robotics. So currently we are also working on like micro robots, say mixing of passive particles or some other things using micro robots, where we can control this motion of the micro robots. So how you can move these so that with a minimum number of robots you can mix it.
These are self-propelled robots.
Yes, these are self-propelled robots. So there is a group in Sweden who are building this, and we have developed the model to predict it. Then we have used reinforcement learning to move those robots so that they will learn by itself when they're moving. So in which direction they have to move so that there will be better mixing. So there are applications which we can connect, but directly these are mostly physics based.
Thank you very much.
Thank you, Pallav. It was nice presentation. Most of my question, my doubt, you already answered it. But I have still one
Yes.
doubt like this. When you have to be develop the model, most of the things you have take by the on observations.
Yes.
Yes.
No,
Most
these
of the
observations means the, few of the models are separately available. Say, for example, VSEC model is very popular in guidance, collective dynamics of birds and other things. But it don't consider the effect of the predation. It just the active system, which I was showing in the initial slides. That's how I have also started, like pure active system, how it will move, compare with the VSEC systems and so on. So uh, directly comparison is a bit difficult. Validations in these fields is almost impossible. Uh, but we are trying to do few experiments, particularly with fish. We are doing some experiments. As I said, I am not including those here. We are not yet ready to exactly doing that. We have done some experiments with crowds and so on. So there are few things.
really good. If you prove like with X-Men, it will be, I am say that one of the wonderful research. I really, because there is just so many applications. Like one, you already say that you have to be a self trained your micro robotics or
Yes.
self-drop the spine, all these things. So many applications.
Yes.
But really, physics behind all observations, we need a more and more validation like this.
Yes.
Thank you. Yes.
Yeah.
Very nice, and you putting the things very systematically. Yes.
Thank you. So, it's-
We extend our heartfelt thanks to our keynote speakers for delivering such an inspiring and thought provoking presentations. Your insights and expertise have greatly enriched our understanding. Now, I would request our session chairs, Dr. Anil Kumar and Dr. Tikendranath Verma, to facilitate our keynote speakers, Professor Dr. Pallab Sinha Mahapatra and Professor Dr. Atul Sagade. Can we have a round of applause, please? Professor Dr. Atul Sagade. A round of applause, please. We would also like to express our sincere gratitude to the session chairs, Dr. Anil Kumar and Dr. Tikendranath Verma, for their exceptional efforts in conducting today's session. Your contributions have been invaluable to the success of this event. I would like to invite Dr. Basant Singh Sikarwar to facilitate our session chairs. Can we have a round of applause for our session chairs, please? Any poster presenters, please move to E2 to auditorium for your presentation. Thank you.